Good morning, everyone. A very good morning to all of you, bacho. We are live. We are back on exam dos. We are back with the ESC Officer Series for solving engineering services PYQs on electrical machine, part number 4. So today we are going to continue seeing the problems based on DC machine. So come on, everyone, join quickly, everybody. ज्वाइन क्विकली एवरीवन, जल्दी से आ जाइए सभी लोग. वी आर अबाउट टू स्टार्ट. चलो 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 भाई, चलिए. लेट मी स्टार्ट विद द फर्स्ट क्वेश्चन. ESC 2012 मैच द कॉलम. ESC 2012 match the column. So this is the analogy between electric and the magnetic circuit. So magnetic flux is analogous to current. MMF is analogous to EMF. Reluctance to resistance, permeability to conductivity. So 2413. See, 2413. Okay. ESC 2015. A magnetic circuit has 150 turns coil. Area length is given. H is asked and mu r is asked if the current and the flux is given. H and mu r. ESC 2015, everybody. Find the value of H and mu r. So H is beta Ni by L. So this is H. Now reluctance, or you can say एक और तरीके से B is phi by A. Six by 12,000, so 1 by 2,000. Okay. So it should be somewhere around how much? 10,000 by 8 pi, sorry. Around 400. So it should be around 400. So answer should be A. Next, again ESC 2015. In electromechanical energy conversion, a magnetic field is used as a medium rather than electric field. Why? Rather than electric field. Why? Why do you use magnetic field? The answer is A. Energy density of magnetic field is much greater than electric field. Therefore, for same energy, we need less volume and size of machine reduces. Electric field energy density is low, magnetic field energy density is high. Fourth one, ESC 2016. The electromechanical energy conversion principle are developed with the field energy being magnetic or electric as the basis. This approach can only deal with the steady state analysis but not the transient state analysis. बताइए. This can only deal with the steady state analysis but not the transient state analysis. The answer is D. Because the field energy is the magnetic energy, not electric energy. The principles are based on the basis of magnetic energy. Okay. And yes, it deals with the steady state analysis. That means when the system has a constant amount of magnetic field, constant angle, then only we can talk about the torque. Steady state में बात होती है. ESC 2021. If the flux linkage versus current characteristic is linear, that is psi versus I is linear, then what happens? Then beta energy is equal to co-energy. In case of rectangle, the diagonal divides it into two equal parts. The area above the line is the energy, area below the line is co-energy. So in case of a straight line, it will get divided into two equal parts. So the answer is C. Very good, Rohan bhai. Next, ESC 2022. There are additional losses that arise from the non-uniform current distribution in the conductor and the core losses generated in iron due to distortion of flux distribution from such load current. Such losses are known as the losses that arise due to the non-uniform distribution of current and the magnetic field or the magnetic flux distortion due to such distribution of current. करंट नॉन यूनिफॉर्मली डिस्ट्रीब्यूटेड और इससे बनने वाले मैग्नेटिक फ्लक्स से जो लॉसेस आएंगे दे आर कॉल्ड एज स्ट्रे लोड लॉसेस. The meaning of the word stray is we do not know the location of such losses, and load means they depend on the current. Okay. चलिए next ESC 2022. If the magnetic core has constant permeability by making air as a medium for a coil current and the resultant flux linkage, then permeability is constant. So yeah, basically you are using air as a medium then, because psi versus I is linear. अगर म्यू कांस्टेंट होता है ना तो मैग्नेटाइजेशन कर्व इज लीनियर. इफ म्यू इज कांस्टेंट, magnetization curve is linear, and just now I proved that in such a case energy and co-energy are equal. ESC 2008. When is the mechanical power developed by a DC motor maximum? When is the maximum power developed? Very easy question beta. When is the maximum power developed? बोलिए. Back EMF is equal to half of the applied voltage. Again, this is the application of maximum power transfer. This is a standard derivation that you do in machines course for maxima. Derivative is 0. So it is V by 2. Next, ESC 2008. ESC 2008. Develop power, torque, EMF, speed. ESC 2008, you have to match the proportionality Develop power E into I, torque Ia into phi, EMF N into phi, speed EB upon phi. A option 2413. Very good, Sakshi. Question number 10, ESC 2008. A shunt generator has a critical resistance 200 at 800 RPM. Now, if you increase the speed to 1000 RPM, what is the critical resistance? What is the critical resistance? Okay. So this is at 800 RPM. This is at 1000 RPM. The open circuit characteristic, or you can say no load characteristic. So this resistance is 200. It is asking me this resistance at 1000 RPM. Now, how do you calculate the critical resistance? Basically, beta, what you do is you choose 2 points. You choose 2 points on the curve. Okay. And you calculate the slope between them. Okay. Now, beta, keeping the field current same. Keeping the field current same. Suppose I am increasing the speed. My EMF will increase, correct? Keeping the field current same, if I am increasing the speed, my EMF will increase. Ia for phi is same. Okay. So now what is RCR? The field current is still the same. EMF has changed because of speed. So I take 1000 by 800 common. Now this value E2 minus E1 upon IF2 minus IF1. So that is 250. Okay, 250. So you can say shortcut, if you can remember, critical resistance is directly proportional to speed. ओके डायरेक्टली आप याद रख सकते हो, मैंने डिटेल में समझा दिया क्रिटिकल रेजिस्टेंस होता क्या है, बट डायरेक्टली याद रखना है तो यू कैन रिमेंबर इट इज प्रोपोर्शनल टू द स्पीड. क्लियर हो गया द कॉन्सेप्ट ऑफ क्रिटिकल रेजिस्टेंस. चलिए 11, which is the following curve represent the speed torque characteristic of a series motor ESC 2008. Again, series motor, come on everybody. Which of the following curve represents a series motor? Yes. Rectangular hyperbola. Very, very popular curve. And this curve shows that at less torque, the speed is very, very high. At less torque, the speed is very high. That is why series motor should not be run at no load. The curves pertain to the DC motor: speed versus current of shunt, torque versus current of shunt, speed versus current of series, torque versus current of series. चार कर्व हैं, स्पीड वर्सेस करंट शंट का, स्पीड वर्सेस करंट सीरीज का, टॉर्क वर्सेस करंट फॉर शंट एंड सीरीज. चलिए बताइए, पहले दोनों शंट के बताइए, स्पीड और टॉर्क, फिर आपका सीरीज का. So what is the speed versus current of shunt? This one. Because the characteristic of a shunt motor is कि speed का drop बहुत कम होता है. The drop in the speed is very, very less. Okay. Now this should be 1. This is series N versus IA. Now this is like parabola, series T versus IA. This is linear, then saturation. So 4, 3, then 1, 2. 4, 3, 1, 2. The option. 4, 3, 1, 2. Armature MMF waveform of a DC machine, ESC 2010. Straightforward question. MMF waveform of armature in a DC machine, triangular. And the magnetic field is saddle shaped. The armature MMF is triangular and the armature flux density is saddle shaped. Okay. ESC 2010 for a p-pole machine. The relation between electric and magnetic mechanical degree is very easy question. P-pole machine, relation between electric and mechanical degree. D. Theta electrical is P by 2 theta mechanical. ESC 2010 again. Consider the following part of a DC machine. Which of the above parts are subjected to iron loss? Which of the parts are subjected to iron loss? So where your iron loss is occurring? Armature core and also pole shoes. कल भी मैंने बताया था ना. But since pole shoes is not in the option, so we can only say armature core. कल किया था ना same question. ESC 2010. When large current are required, it's necessary to use lap winding. In lap winding, equalizing connections are needed. Okay, tell me which is correct. When large current are required, it is necessary to use lap winding. In lap winding, equalizer connection are needed. Yes, both are correct. This is basically talking about equalizer ring. What is the purpose of equalizer ring? Avoid circulating current. Reaching brushes. Next, ESC 2011. The maximum efficiency occurs in a separately excited generator when terminal voltage is this, EMF is this. If armature resistance is 0.2, the stray losses are बताइए. देखो फर्स्ट आई विल कैलकुलेट IA. It is a generator. So we can say constant loss equal to variable loss. So 2000 watt. ESC 2011 again. A 8-pole DC generator has a wave-wound armature containing 32 coil of 6 turns each. Flux per pole is 0.06 Weber. Machine is running at 250 RPM. What is the EMF? कौन से डाउट का सॉल्यूशन नहीं मिल पा रहा है? बताइए, व्हाट इज द ईएमएफ इंड्यूस्ड? तो वेव वाउंड A is 2, P is 8, speed is 250 RPM, Y is 0.06. Now Z. So first of all, turns. 32 coil of 6 turns each, 192. Each turn has 2 conductor, so 384. Hundred, 10,000, 40. 6 by 100, so 1000, sorry, 10,000, 4. Answer is C, 384. Okay. चलिए, how many segment will be there? ESC 2011 again. How many segment will be there for the commutator of a 6-pole DC machine having a wave-wound armature with 72 slots? With 72 slots. Answer is B. Slot equal to coil equal to commutator segment. Next, again ESC 2011. Which of the following statement is correct for the ideal field excitation during starting in case of shunt and compound motor? बताइए. What should be the field excitation? It should be maximum, because at starting you need high torque. तो देखिए, torque is proportional to phi into Ia. So at start, phi should be maximum to make torque equal to maximum. Again, ESC 2011, in a certain case, a shunt generator failed to build up voltage. Shunt field resistance should be more than critical resistance to generate voltage. बताइए भाई. हाँ भाई, पुरानी प्लेलिस्ट देख लो, हो जाएगा उससे. यस, सी. RF should be less than RCR, not greater. So reason is false. Reason is false. अगर वोल्टेज जनरेट करना है तो आरएफ को आरसीआर से कम होना होगा। वो ये नहीं कह रहा कि आरएफ बड़ा है, वो कह रहा है बड़ा होना चाहिए वोल्टेज बनाने के लिए। गलत है, छोटा होना चाहिए टू जनरेट द वोल्टेज। नेक्स्ट, ESC 2012, the air gap between yoke and armature is kept small. Why do you keep the smaller air gap? बोलिए, why do you keep the smaller air gap? To achieve a stronger field, less reluctance, more flux, correct, and hence more torque. ESC 2012, in a DC machine running with a heavy load and with the brushes located on GNA, sparking occurs at brushes during commutation because of. Why does the sparking occurs during commutation at the brushes? Very simple question. Why does the sparking occurs? Because the MNA shifts. Neutral axis means where the EMF is zero. अगर GNA पे कम्यूटेशन हो रहा है और न्यूट्रल एक्सिस कहीं और है, if the commutation is occurring at GNA but the neutral axis is somewhere else, so that means that GNA where the shorting is occurring, EMF is non-zero, which will lead to sparking. If you are doing short circuiting without zero voltage, it will cause sparking. बिना जीरो वोल्टेज के अगर आप शॉर्टिंग करोगे तो स्पार्किंग आएगा. Again, ESC 2012, the speed of a DC motor is related to back EMF and flux in the following ways. Very easy. How is the speed related with the back EMF and the flux? बोलिए. B. Speed is proportional to EB upon phi. Next, ESC 2012. A 4-pole DC generator is running at 1500 RPM. What is the frequency of current in the armature winding? Frequency of current in the armature winding. Use the concept of synchronous to convert speed into hertz. A. ESC 2012. ESC 2012, a separately excited DC generator is feeding a DC shunt motor. If the load on the DC motor is reduced to half, then a generator is feeding a motor. If you reduce the load to half, then what will happen? The current of both are halved. देखो भाई, जनरेटर का करंट ही मोटर में जा रहा है ना. The generator current is going into the motor. So if you are reducing the power to half, the current will become half for both. ESC 2012. A series motor is running at rated speed and rated voltage, feeding a constant power load. If the speed has to be reduced to 0.25 pu, the supply voltage should be reduced to. And MMM beta, in DC machine also, the induced EMF in armature is AC. It's not DC. Yes, the answer should be B. देखो क्या होगा. Power is constant, 1 pu. Four pu. Now it is a series motor. V is equal to EMF 0.5 pu. Okay, because in a series machine phi is proportional to Ia. So answer is 0.5. Next, ESE 2012. The overall efficiency of a shunt generator is maximum when the variable loss equals. When is your efficiency maximum? When the variable loss equals constant loss. Simple condition for maximum efficiency. ESE 2013. A triangular MMF is produced in the air gap of a machine. Such a wave is produced by. Who produces triangular MMF? ESE 2013. Rotor of a DC machine. Rotor means armature. In a DC machine, armature is on rotor. At 1200 RPM, EMF is 200 volt for a current of 15 ampere. What is the torque developed? Again, ESE 2013. So torque will be 40 A. चलिए नेक्स्ट ESE 2013. A 4-pole lap mount generator has developed power P, EMF E. Two adjacent brushes are removed as they are worn out. If the machine operates with remaining brushes, the developed voltage and power. Now see very carefully. When you remove the brushes, then you can short the winding because the winding will still be connected to commutator. So suppose this voltage is E. This is also E. Okay. So net voltage that I will get is E. Okay. Now what happens? The current. See, lap mount P is 4, A is 4. So current per path is IA by 4. If this is IA by 4, suppose this path has a resistance R, then 3 coil in series will have a resistance 3R. So the current will be 1/3. भाई एक R से अगर IA by 4 है तो 3R से IA by 12 होगा. So basically this current is IA by 3. So power EIA by 3, which is P by 3. So none of these. ठीक है. तो बहुत जगह ये बोला जाता है कि ब्रश हटने से ओपन सर्किटिंग आती है. नो, when you remove the brushes you short circuit the coil because it is still connected to armature. हाँ, अगर अपोजिट ब्रशेस रिमूव कर दोगे तो जीरो होगा. ESE 2013 again, try this out. ESE 2013 बच्चों. A 6-pole DC armature has a simplex lap connected 720 conductor. 3 turn per coil, 4 coil side per slot. Number of slot in the armature and whether you can use the equalizer or not. ESC 2013 it is, each coil has 3 turns. Number of conductor per coil, 6. Okay, we have 720 conductors. Each coil has 6 conductors, so 120. Each coil has 2 sides. One slot equal to 4 coil side. Okay, every coil has 2 sides, na? And one slot is accommodating 4 coil side. So basically we have how many slots? 60 slots. Okay, we have 60 number of slots. Now the next question is whether equalizer is possible or not. There are two options that the equalizer is possible and it is not possible. So it is a lap connected. So we will use the equalizer connection. Lap connected है, we will use the equalizer connection. ESC 2013 फ्लक्स पर पोल बताना है, चलिए फटाफट. फ्लक्स पर पोल. $500 4 by 2 is 2, 12,000, 500 by 12,000. Okay, 40 milliweber approximately. Answer is C. चलिए next, ESC 2013 again. Consider the following statements. The armature MMF in a DC machine is, it is stationary with respect to field pole. Why? See, field MMF is stationary to produce torque. There must be no relative motion between two MMF. Okay, so if it is stationary with respect to field pole, it will rotate with respect to armature. एक चीज सोचो यार, फील्ड पोल यानी कि स्टेटर, स्टेटर के रेस्पेक्ट में मैं स्टेशनरी हूं यानी कि मैं रुका हुआ हूं, बट आर्मेचर तो घूम रहा है. तो अगर आर्मेचर पे खड़े होके देखें तो मैं रोटेटिंग नजर आऊंगा. इफ आई एम स्टैंडिंग स्टेशनरी, इफ आई एम स्टैंडिंग स्टिल, but armature is moving. Now if I stand on the armature, it will appear to me that the armature MMF is rotating. Armature MMF speed is 0, but armature is moving. So if you observe from armature, the MMF is moving. ESC 2013, maximum power is developed when? This question we already attempted. EMF is half of the applied voltage. Again, ESC 2013, EMF of a DC machine running at 750 RPM is 220. Find the increase in field flux to generate 250 volt at 700 rpm. I need to generate 250 volt at 700 rpm. How much increase in flux should be there? बोलो भाई। फिफ्टीन 14 220 और 88 308 so it will be 67 672. आंसर इज सी। कर सकते हो बेटा, किसी भी AE एग्जाम के लिए ESE PYQ बनाना अच्छी बात है। Question 37 again, ESE 2013. The speed of a separately excited motor is varied by varying the armature voltage in the range 0 to the base speed and by varying the field current above base speed. It is suitable for constant. ये मैंने कॉन्सेप्ट कल बताया था बेटा। Constant torque drive till the base speed and constant power drive above base speed. Below base speed constant torque drive होता है, above base speed constant power drive लेते हैं। ESE 2013 again. A DC shunt motor is required to drive a constant power load at rated speed while drawing rated current, neglecting saturation and losses. If the terminal voltage and field current are halved, then terminal voltage and the field current are halved, then what will happen बच्चों? The answer will be B. देखिए, neglecting losses means RA is 0. Now speed is proportional to E by phi or E by IF. Okay. So when V2 is equal to V1 by 2, IF2 is equal to IF1 by 2. Speed remains same. But it is saying constant power so V into IA is constant. So if V2 is half, IA2 will be doubled. Okay. Current will become doubled. Chaliye, next. ESE 2013 again. The DC series motor is best suited for traction work because why do you use the series motor for traction? बोलिए। Because torque is proportional to square of current and speed is inversely proportional to torque. Hyperbola. Speed is inversely proportional to torque. Simple. चलिए ये नेक्स्ट क्वेश्चन देखिए, ESE 2013. In large DC motor drive, reversing role of a steel mill and in generator which supply them, large fluctuation of current cause high voltage induced in the coil located in the adjacent commutator segment. This may lead to flashover between the brushes. ये बेसिकली कह रहा है कि डीसी मोटर जो कि स्टील मिल में काम आती हैं और उन्हें चलाने वाले जनरेटर्स में करंट का फ्लक्चुएशन ज्यादा होने से कम्यूटेटर में आग लग सकती है. ओके. Now to counteract the possibility of a flashover, a compensating winding is embedded in the slot on the pole faces, connected in series with armature winding, which supplies the MMF that magnetizes in opposite direction to that of a armature MMF. ठीक है. तो आप क्या करते हो, एक कंपेंसेटिंग वाइंडिंग लगाते हो जिसकी मदद से आर्मेचर एमएमएफ के अपोजिट एमएमएफ आता है. तो आंसर इज okay. That is why DC machines are discouraged to be used at high current because it can lead to commutator flashover. Next, ESC 2013. DOL starter is used to start a small DC motor. DOL means applying V-rated डायरेक्टली. जब आप डायरेक्टली रेटेड वोल्टेज लगा देते हो ना, उसे DOL कहते हैं. DOL starter limits the initial current drawn by the armature circuit. No. स्मॉल मोटर में DOL starter क्यों लगाते हैं? Why do we use DOL starter? Because we want to save the cost. I do not want to use the starter and increase the cost. And in small motors, the current is already very low. स्मॉल मोटर्स का करंट इतना हाई नहीं होता कि मैं उसके लिए स्टार्टर लगाऊं. स्मॉल मोटर्स का करंट कम रहता है. दैट इज व्हाई आई प्रेफर टू डायरेक्टली स्टार्ट देम. अ टाइम वेरिंग फ्लक्स कॉजेज ईएमएफ. व्हाट लॉ डज दिस स्टेटमेंट रिप्रेजेंट? ESC 2014. What is the law that says time varying flux causes EMF? Faraday's law. Correct? Faraday's law. Simple. ESC 2014. Assuming a uniform distribution of current over the armature surface conductor, the shape of resultant armature MMF in space of a loaded DC machine is a symmetrical. यूनिफॉर्म डिस्ट्रीब्यूशन के लिए एमएमएफ का शेप कैसा आएगा? ट्रायंगुलर with peak at the interpolar axis, that is Q axis. Yes. Armature MMF is maximum at Q axis and it is 0 at D axis. FAR का maximum value Q axis पे आता है, D axis पे 0 आता है. ठीक है. यूनिफॉर्म डिस्ट्रीब्यूशन माना जाता है करंट का, यानी करंट पर यूनिट लेंथ इज कांस्टेंट. ESC 2014. A series motor with resistance between terminals of 1 ohm. It means RA plus RSE. Runs at 800 RPM from 200 volt supply taking 15 ampere. Now I want to reduce the speed to 475 RPM. Same voltage and current. What is the resistance to be inserted in series? How much resistance should I apply or connect in series? चलो चलो भाई, quickly. How much resistance should we connect in series? So what is EMF? V minus IA RA plus RSC. What is the speed? 800. Okay. Now beta, it is a series motor. (25 into 19). 25 into how much? 432. Okay. आंसर इज डी 5 ओम. ठीक है 5 ओम. Next, ESC 2014. A series motor of resistance 1 ohm across terminal run at 1000 RPM at 250 volt taking a current of 20 ampere. Now you have added a 6 ohm resistance in series taking the same current. The new speed. Just reverse of the previous question. पिछले क्वेश्चन का जस्ट उल्टा ये पूछ रहा है. इस बार रेजिस्टेंस दे रखा है बेटा. This time resistance is given, it is asking the speed. Load generally means power beta. Load generally means power Naila. चलो भाई. Same current 140. I is same, phi is same. So EMF is proportional to speed. Answer is C. Okay, C. चलिए next. ESC 2014. In a DC machine for same number of slots and same current in the armature conductor, which will have higher EMF. किसके अंदर EMF ज्यादा होगा? Wave winding. Because parallel path is less and EMF is inversely proportional to parallel path. चलिए next. ESC 2014. In a DC shunt generator, the build-up induced voltage at its terminal is given by the intersection of the field resistance line with the no load characteristic. Yes, right. We take the intersection of the field resistance and the no load characteristic. The generator fails to build up at its terminal when the slope of FRL is higher than the straight line portion of no load characteristic. अगर फील्ड रेजिस्टेंस का स्लोप ज्यादा होगा नो लोड से तो वोल्टेज बिल्डअप नहीं होगा. ये भी बात सही है. बट इज इट द करेक्ट एक्सप्लेनेशन? नो, ये एक्सप्लेनेशन नहीं है. तो एक कंडीशन हो गई बेटा कि वोल्टेज बिल्डअप कब नहीं होगा. ओके, तो इंटरसेक्शन से मिलता है, दैट इज करेक्ट. बट इट विल फेल टू बिल्ड अप वोल्टेज व्हेन द स्लोप इज हायर. दैट इज नॉट द करेक्ट रीजन. दैट इज ऑल्सो अ ऑब्जर्वेशन. बल्कि ये कह सकते हो स्टेटमेंट 2 का रीजन स्टेटमेंट 1 बन सकता है. स्टेटमेंट 2 का रीजन स्टेटमेंट 1 बन सकता है कि अगर स्लोप ज्यादा हुआ तो इंटरसेक्शन नहीं मिलेगा तो वोल्टेज बिल्डअप नहीं होगा. नेक्स्ट, ESC 2015. When the armature iron of a DC machine rotates, it goes through the influence of north and south pole, thus causing cyclic variation of the linked flux, resulting in the occurrence of hysteresis loss in the armature core. सही बात है. आर्मेचर का फ्लक्स बार बार बदलता है. इट गोज अंडर नॉर्थ साउथ. तो अगेन एंड अगेन द फ्लक्स इज रिवर्सिंग, कॉजिंग हिस्टेरेसिस लॉस. Laminated construction limits the hysteresis loss to a lower value. No, laminated construction is for eddy current. Lamination is used for reducing eddy current losses. ESC 2015. In DC machine, the field flux axis and armature axis are along. फील्ड फ्लक्स और आर्मेचर एमएमएफ की एक्सिस कौन सी होती है? डी एक्सिस एंड क्यू एक्सिस. आर्मेचर एमएमएफ इज ऑलवेज अलोंग क्यू एक्सिस. क्वेश्चन 50, ESC 2015. A shunt motor supplied at 250 volt runs at 900 RPM. Current is 30. Resistance 0.4 ohm. Find the resistance required in series with armature to reduce the speed to 600 when current is 20. Try this. आया भाई 4.17। चलिए लेट अस सी द फर्स्ट ईएमएफ 250 okay. Now in a shunt machine we can assume the flux to be constant till the terminal voltage is constant. शंट में ना फ्लक्स को कांस्टेंट मान सकते हो जब तक टर्मिनल वोल्टेज सेम है। तो व्हाट इज द न्यू ईएमएफ? टू बाय थ्री so this is 250 158.66 plus 30 3.04 sorry current is now 20 4.16 D. Okay, the answer is D. ESC 2015. Next, internal characteristics are plotted between. What is the graph of the internal characteristic? Internal characteristic is between armature current and the voltage after armature reaction. ठीक है, आर्मेचर करंट एंड द वोल्टेज आफ्टर आर्मेचर रिएक्शन। इसके बाद IaRa ड्रॉप लेके एक्सटर्नल कैरेक्टरिस्टिक मिलता है। ठीक है, तो इंटरनल कैरेक्टरिस्टिक इंक्लूड्स आर्मेचर रिएक्शन ड्रॉप। आफ्टर दिस यू टेक IaRa ड्रॉप एंड यू गेट द वैल्यू ऑफ एक्सटर्नल कैरेक्टरिस्टिक। द ड्रॉबैक ESC 2015, the drawback of armature resistance control. आर्मेचर रेजिस्टेंस वेरी करा के जो स्पीड कंट्रोल करते हैं, when we vary armature resistance to control the speed, what are the drawbacks? A large amount of power is lost. Yes. Speed below the base speed is obtained. Yes. And the speed varies with the load. Yes. Basically, speed regulation increases. स्पीड का ना नो लोड से फुल लोड तक का फ्लक्चुएशन बढ़ जाता है। तो स्पीड वेरीज विद लोड। स्पीड वेरीज विद लोड। ओके, द स्पीड इज नॉट कांस्टेंट इन दैट केस। एज यू वेरी द लोड, द स्पीड विल वेरी बाय larger amount. ESC 2015 again. A DC motor running at 2000 RPM has a hysteresis and eddy current loss. The flux is constant. Speed is 1000 RPM. What is the total iron loss? So when beta flux is constant in a DC machine, hysteresis loss is proportional to speed, eddy current to speed square. So total is 300. Okay. Remember this. ESC 2015, the speed of a DC shunt motor in both direction can be obtained by. In both direction can be obtained by Ward-Leonard method. Ward-Leonard method can increase the speed above the base speed and below the base speed. वार्ड लियोनार्ड के अंदर आर्मेचर वोल्टेज कंट्रोल भी होता है, फील्ड कंट्रोल भी होता है. वी कैन इंक्रीज और डिक्रीज द स्पीड. ESC 2015, in a 10 horsepower 240 volt DC shunt motor having a armature resistance of 0.5 ohm, full load current of 40 ampere is started by a starter such that section of the resistances are in series should limit the current to 150%. The steady state EMF developed by the machine at full load when armature of the starter is moved to the next step. देखिए बेटा, in this question maximum current is 150% of full load and the minimum current that we will take so what is V? V is 240 or you can say R1 total resistance. Okay. Now EMF increases, current reduces. When current is 40 ampere, resistance is cut. So basically what I can tell कि उस समय पे EMF कितना होगा? 80 volt. ठीक है, 80 volt. So at that time resistance will EMF will be 80 volt. तो जब आप नेक्स्ट स्टेप पे मूव करेंगे द EMF विल बी 80 वोल्ट. ओके, बट एक सेकेंड, ये तो फर्स्ट स्टेप पे हुआ ना. अगर अगले स्टेप पे भी निकाला जाए तो नाउ न्यू रेजिस्टेंस विल बी 160 by 60, so 16 by 6, 8 by 3. Okay, now again जैसे आप रेजिस्टेंस काटते हो ना तो आपका करंट बढ़ जाता है वापस, तो मैंने इसीलिए मैक्सिमम करंट यानी 60 का यूज किया. तो न्यू EMF will be when current again reaches the minimum value 320 by 3 240 minus 320 by 3. मेरे हिसाब से तो यार देखो 80 ही आना चाहिए. द आंसर शुड बी 80, क्योंकि जब आप नेक्स्ट स्टेप पे जा रहे हो उस समय पे आपका EMF 80 है. ओके, तो आंसर शुड बी 80. चलिए नेक्स्ट, इंटरनल कैरेक्टरिस्टिक इज प्लॉटेड बिटवीन, ये अभी हमने किया, आर्मेचर करंट एंड द वोल्टेज जनरेटेड आफ्टर आर्मेचर रिएक्शन ESC 2015. Consider the following factor for a DC machine which are responsible for decrease in the terminal voltage of a shunt generator. ESC 2016. Which factors are responsible? 2 and 3. Okay, 2 and 3. वोल्टेज घटाने के लिए 2 और 3 रिस्पॉन्सिबल होते हैं बेटा. Interpole basically cancels armature reaction, so it does not reduce the voltage. ESC 2016, a DC motor develops a torque of 150 in a certain operating condition. From this condition, 10% reduction in field flux and 50% increase in armature current is made. What is the new value of torque? What is the new value of the torque? T2 by T1 flux is reduced by 10%, 1.35, 13.5 into 15, 202.5. Simple question B. Next, ESC 2016 again. A DC machine having a symmetrical closed circuit armature winding sinusoidal flux density will have a sinusoidal voltage in the individual coil. The resultant brush to brush voltage will have a waveform. देखो ये कह रहा है अगर फ्लक्स डेंसिटी साइनोसोइडल होगा तो जो ईएमएफ बनेगा कॉइल में वो भी साइनोसोइडल होगा, तो ब्रश के बीच में वोल्टेज कैसा दिखेगा? तो आंसर शुड बी सी। रेक्टिफाई होके मिलता है बेटा तो कांस्टेंट होगा लेकिन उसमें थोड़े रिपल आएंगे। ओके, देयर विल बी सर्टेन रिपल्स इन द वोल्टेज, देयर विल बी रिपल्स, क्योंकि साइनोसोइडल वोल्टेज में ना फ्लैट टॉप्ड के मुकाबले ज्यादा रिपल आते हैं। साइनोसोइडल वेवफॉर्म हैज मोर रिपल एज कंपेयर टू फ्लैट टॉप्ड। Next, a cumulative compound motor runs at 1500 rpm at full load. If the series field is shorted, then the speed. बेटा जेके एसएसबी में मतलब ये मान के चलो 70-30 का रेशियो रखो थ्योरी न्यूमेरिकल्स का, तो इसीलिए मैं कह रहा हूं ईएससी के पीवाईक्यू करो क्योंकि ईएससी में भी वैसा ही आपको रेशियो मिलेगा। हाँ, रिकॉर्डेड कोर्स चलेगा ना, विद्युत बैच बेसिक से ही है। स्पीड इंक्रीजेस, तो व्हाट हैपेंस when series field is shorted, phi SC becomes 0. So then flux becomes phi SH, reduces, so speed increases. ठीक है, चलिए नेक्स्ट। The speed of a DC motor is ESC 2016. ये भी हमने कर रखा है, डायरेक्टली प्रोपोर्शनल टू ईएमएफ, इनवर्सली प्रोपोर्शनल टू फ्लक्स। नेक्स्ट, ESC 2016 induced EMF in the armature conductor of a DC machine. EMF कैसा आता है आर्मेचर कंडक्टर में ESC 2016? ट्रैपेजॉइडल या फ्लैट टॉप्ड आप कह सकते हो। ESC 2016 for a DC shunt generator to self-excite, the condition to be satisfied are there must be some residual magnetism, it must be in a proper direction, and the shunt field resistance must be less than critical value. RF should be less than RCR. ये देखिए, armature structure of all rotating machine are laminated in order to reduce the eddy current loss. The armature winding of both DC and AC machine will have to deal with AC current only. बोलिए, ESC 2016 assertion reason है। तो A, आर्मेचर में AC ही आता है भाई। Armature only contains AC, whether the machine is AC or DC, armature has AC. ठीक है, A. Next, DOL starter is for starting DC motor is used for the reason of economy. DOL starter limits the current to a safe value. ये मैं बता चुका हूं बेटा ऑलरेडी कि DOL इसीलिए करते हैं क्योंकि मुझे खर्चा नहीं करना। I don't want to spend, So directly I will start the motor at rated voltage, but it will not limit the current to a safe value. The current will be high. Next, ESE 2016. For constant voltage applied to the terminal, armature resistance effect in the operation is to reduce the speed, cause the drooping speed versus load. सही कह रहा है, आर्मेचर रेजिस्टेंस से जो है ना लोड बढ़ने के साथ स्पीड गिरती है. Why? As load increases, IA increases, EMF V minus IARA decreases, speed decreases. Effect of armature demagnetization with decreasing load is to reduce the drop in the operating speed and can be designed to give a rising speed versus load characteristic, which may result in a possible runaway. ये कह रहा है लोड घटने के साथ आर्मेचर का डीमैग्नेटाइजिंग इफेक्ट, आर्मेचर रिएक्शन का डीमैग्नेटाइजिंग इफेक्ट कम होता है, जिससे स्पीड का ड्रॉप कम होता है और स्पीड लोड के साथ बढ़ सकती है, जिससे रनअवे आ सकता है. नो, स्पीड बढ़ नहीं सकती अंटिल यू हैव अ सीरीज वाइंडिंग. स्पीड कैन नॉट इंक्रीज विद लोड लेकिन एक सेकेंड, स्पीड लोड के साथ आर्मेचर डीमैग्नेटाइजेशन का जो इफेक्ट होता है वो स्पीड के ड्रॉप को रिड्यूस करता है, बट स्पीड जो बढ़ती है वो सिर्फ डिफरेंशियली कंपाउंड में बढ़ती है, नोवेयर एल्स. ओके, स्पीड जो है सिर्फ डिफरेंशियली कंपाउंड में बढ़ती है. ये बात क्लियर है, स्पीड बस डिफरेंशियली कंपाउंड में बढ़ती है और कहीं नहीं बढ़ती है. बारी मैं चेक भी कर लेता हूं, विच क्वेश्चन इज इट. 66. हाँ ठीक है, चलो ये ट्राई करो जरा जल्दी से. ESE 2018. आया भाई इसका? देखो पहली बात तो ये कि दिस वर्ड शुड बी पेरीफेरी। चलिए देखते हैं। A 24 slot 2 pole lap wound DC machine has 18 turns per coil, flux density 1 Tesla, length and the radius is given. Poles cover 80%. Okay. Now area per pole. Radius is how much? Radius is 10 centimeter. Length 20 centimeter. And poles are 2. And it is covering only 80% of the area. B average into area per pole. 0.0502 Weber. Now EMF. Omega is 153.2 and conductors 18 turns per coil, 24 slot. So I am assuming double layer winding. So turns are how much? 432, right? Conductors are twice the number of turns, 864. मैंने स्लॉट और कॉइल को बराबर माना है बेटा डबल लेयर के एजम्पशन पे. Now poles are 2, parallel path can only be 2. पैरेलल पार्ट 2 ही हो सकते हैं बेटा जब पोल 2 हैं. लैप मान लो चाहे वेव, क्या ही फर्क पड़ता है. When there are only 2 poles, lap and wave do not matter. The closest option is B. Closest option is B. Okay. चलिए next. ESC 2018 again 220 volt compound generator connected in the long shunt has the following parameter. Current is 150 ampere at rated voltage. EMF should be. Now beta in long shunt directly I can calculate ISH. .75. .15. Answer is B. 243. ESC 2018 again. A DC shunt motor has the following characteristic. On no load, it draws 5 ampere. At what speed it will run when delivering a torque of 150? नो लोड पे ये 5 एम्पियर ड्रॉ करती है. तो व्हाट विल बी द स्पीड व्हेन इट डिलीवर्स अ टॉर्क ऑफ 150? पहले तो लेट अस कैलकुलेट ISH. $248.125 volt. Okay, so now I can calculate the machine constant into flux. Okay. $880 RPM. आंसर आ गया 880 RPM. So ESC 2018, the answer is A. Question 70. The figure shows the plot of speed versus armature current of DC motor with two operating condition. कौन सा बता रहा है एक स्ट्रॉन्गर शंट फील्ड और कौन सा बता रहा है स्ट्रॉन्गर सीरीज फील्ड? बताइए. So this second curve is similar to shunt and the first curve is similar to series. So basically in the first series winding is dominating, in the second shunt is dominating. बट फर्स्ट वाला तो पूरा ही सीरीज का आ गया. तो ये लगाएंगे कि पहले वाला पूरा सीरीज का, सेकंड वाला शंट का है. बिकॉज कंपाउंड मशीन में ऐसा ग्राफ नहीं आता है, ये सीरीज का होता है. तो फर्स्ट वन इज सीरीज, सेकंड इज शंट. ESC 2018 in a progressive simplex lap winding for a two coil side per slot, बैक पिच एंड फ्रंट पिच. इसमें यार ये डेटा गलत छप गया है. फोर पोल 14 slot. Now this is double layer. Two C by P. Coil span होता है by P.
ऑड आती है।
Commutator pitches plus minus 1, plus 1 for progressive, minus 1 for retrogressive. ये आएगा 7/5. ओके, 2C/P होगा. ओके, हाँ ऑप्शन से भी कर सकते हो. नेक्स्ट ESC 2018 इन अ लीनियर कम्यूटेशन. पूछो ऋषभ भाई. In a linear commutation, current magnitude of current in the coil under each pole on a given load remain constant. Magnitude of EMF induced in the coil under each pole on a DC generator on load remains constant. चलो उत्कर्ष भाई, बहुत खुशी हुई जान के कि आपको मदद मिली यार. स्प्रेड कर दिया करो ज्यादा से ज्यादा मेरे भाई. तो आंसर इज बी. बात सही है, लोडेड कंडीशन में ईएमएफ और करंट दोनों ही कांस्टेंट रहते हैं, लेकिन ईएमएफ की वजह से करंट कांस्टेंट नहीं रहता. ठीक है, ईएमएफ इज नॉट द रीजन व्हाई करंट रिमेन्स कांस्टेंट, बट यस इन अ लीनियर कम्यूटेशन द करंट एंड द ईएमएफ रिमेन्स कांस्टेंट. रेट्रोग्रेसिव वाइंडिंग की कंडीशन, रेट्रोग्रेसिव वाइंडिंग बी. YB minus YF YC is negative for retrogressive, so YB is less than YF. Okay, ESC 2019 YB less than YF. Next again ESC 2019 useful flux per pole on no load of a 250 volt 6 pole shunt motor having a wave connected armature winding with 110 turns, resistance and current is given. बताइए, फ्लक्स हमें बताना है. Z is double the number of turns. Okay. Parallel path is 2, poles are 6. 10, 110, 11. तो इसको आप मान लीजिए 10,000. तो ये तकरीबन यही आ जाएगा. C. Answer will be C. ESC 2019 again. Cross magnetizing effect of armature reaction can be reduced by. How can you reduce the cross magnetizing effect of armature reaction? Come on. How to reduce the cross magnetizing effect of armature reaction? Making the pole shoe flat faced. Okay. Then making main field. ये होना चाहिए यार. If FF is much greater than FAR, the effect of armature reaction decreases. क्योंकि फ्लैट फेस्ड क्या, अगर शैम्फर्ड बोलता तो भी समझ आता फ्लैट फेस का मतलब क्या होगा. अगर शैम्फर्ड बोलता तो मैं शैम्फर्ड चुन लेता. चलिए नेक्स्ट ESC 2019 500 kilowatt 500 volt 10 pole DC generator has a lap wound armature. Pole face is covering 75% of the pole pitch. ऐसा एक क्वेश्चन मैंने कल भी कराया था। तो दिस इज 75। आपको तो कंडक्टर चाहिए ना, तो आइए को भूल जाओ। लैप वाउंड कंडक्टर्स होल्स आर 10। 8 इंटू 3/4 6। बट आपको इवन लेना होता है तो 10। कंडक्टर्स मस्ट बी इवन, तो यू विल चूज 10। आप ज्यादा ले लीजिए, कम मत लीजिए, ठीक है। Z मस्ट ऑलवेज बी इवन। नेक्स्ट, ESE 2020 shunt generator supplies a load of 7.5 kilowatt at 200 volt. Armature resistance and field resistance are given EMF. So what is IL? 37.5. 224 वोल्ट, ठीक है। अगेन ESE 2020 कितने पोल दे रखे हैं। 4-pole DC motor is lap wound with 400 conductor, 0.4 Tesla, armature diameter 30 centimeter, current, RPM, torque. Area per pole is pi dl by P. Diameter is 0.3, length is 0.2, poles are 4. 0.06, 0.015 pi. 0.4. IA 25. Z 400. It is lap wound, so pole and parallel path are same. 200 into 25, 5030. ठीक है, it will be 30. Simple. चलिए, second last question. In a unloaded shunt generator, when switch is closed, a small field current is produced, which leads to the generation of still larger voltages due to addition of, बताइए। जब आप स्विच क्लोज करते हैं तो एक छोटा सा फील्ड करंट पैदा होता है, जिससे और बड़ी वोल्टेज बनती है ड्यू टू एडिशन ऑफ, किसका एडिशन होता है? ड्यू टू एडिशन ऑफ रेसिडुअल वोल्टेज। रेसिडुअल वोल्टेज ऐड हो जाती है इन द जनरेटेड वोल्टेज। लास्ट क्वेश्चन, जनरेटर एफिशिएंसी विल बी मैक्सिमम व्हेन वेरिएबल लॉस इज इक्वल टू, दिस वी हैव ऑलरेडी सीन, कांस्टेंट लॉस। तो देखिए, डीसी मशीन के क्वेश्चन भी आपके कंप्लीट हो गए हैं, एंड फ्रॉम टुमारो वी विल स्टार्ट विद द सिंक्रोनस मशीन। ओके, So from tomorrow onwards, we will cover synchronous machine. DC machine is also over. Transformer, DC, energy conversion, and the basic concepts like MMF reluctance. Everything is done. Okay. So I'll see you again tomorrow at the same time. Thank you and have a nice day.